Hello everyone, it's James Governor from Redmonk. We are doing another moderated screencast today. I am really excited to introduce you to Mike Milner, the CTO of Immunio. We're here to talk a little bit about cross-site scripting and how you can remediate that as a problem. Mike Milner, hello, how are you?
Good. James, thanks for having me.
You are very welcome. So I think what we wanted to do was something short, snappy, get people familiar with what actually cross-site scripting is. I think some people probably think they have an idea of it, but you're an expert, so let's hear a bit about that. And then again, look at the tool, bit of demo, see how Immunio actually can deal with this kind of attack.
Yeah, perfect. I figured I'd start with a bit of a background on XSS, some of the basics, some of the basic protections people are probably using today, and then a few of the cases that might not work so well, might not be protected so well. And then we'll hop into a demo and look at how a product like Immunio can make things a little bit more secure.
Great.
All right, so the basics of cross-site scripting. It's been around since the 90s, pretty much since JavaScript has been in browsers. It's an injection vulnerability where you're basically tricking the browser into executing code when it's actually your intent was to just supply some text or some data. This is sort of the canonical example here on the screen. You've got hello first name, like a form letter style, and what you expect is someone will have a first name like Mike in green there, hello Mike, and everything will work like you think.
Mm-hmm.
But then an attacker, being a bit sneaky, sets their first name to be an actual HTML script tag. And in this case, it's just executing an alert box, alert 1, which is just going to pop up a box on the screen. But that's sort of a typical example of what a cross-site scripting attack would look like.
Okay.
So, yeah, you get all these guys.
And I guess the question for
Very
me
common.
then is they are common. They've been around since the 1990s. Why haven't we fixed it yet? Why is this still a vector of attack?
Yeah, I ask this question a lot, and really it's not just XSS. I mean, SQL injection is another big one that's been around for almost 2 decades. You'd think, well understood, it should be fixed. But it really goes down to it's so easy to make a website. It's really easy to make a website. Anybody can do it in PHP, Python, Ruby, Node.js, Java, whatever. But it's hard to make one that's secure because there's so many different attack vectors, so many different techniques being used by attackers that it's hard to keep it all in your head. It's hard for a developer or even a team of developers to really comprehensively always keep things secure because it's easy to make mistakes. And you just need one mistake for the attacker to get in.
Okay, one thing I know in life, it is definitely easy to make mistakes.
Exactly. Now, frameworks are trying to help us out here. And the biggest fix for cross-site scripting has been the idea of this automatic escaping.
Okay.
So usually you don't want user input to get into your templates. You don't want that to be HTML. You don't want it to execute. You just want it to show some text. So most frameworks today, by default, will automatically escape any input that you're putting into an HTML template. And it escapes things like, the less than, greater than, the stuff that defines HTML tags.
Mm-hmm.
It escapes quotation marks and the and sign, the ampersand, which is actually used in the escaping. So it takes most common attack types, cross-site scripting attacks, and sort of renders them harmless by doing this escaping.
So is this one of the reasons that some text editors seem to do weird things to you when you're trying to do your HTML and you're like, why did it not let me do that?
Yeah, and you'll see it in a lot on the web blogs, things where people don't get this quite right, where they'll over-escape, it'll be escaped twice or 3 times, and you'll see characters like these in the output. And obviously, if it's not escaped by all, you might be getting attacked. So it's not trivial to get it correct, which is what leads to some of these vulnerabilities in the first place.
Okay.
So like I said, this auto-escaping takes care of a lot of the basics, but it's not perfect. So a big initial one is that it can be disabled. You can turn off the automatic escaping. So a common example is you've got a blog or something where you've got posts. That's these examples here, and you're trying to put the body of the post. But you want to be able to put things like images and links, maybe bold text and italic text. So you think, oh, maybe I'll allow HTML here. So you can disable escaping just for certain things. And there's basically on the slide here is a few different examples in a few different languages. Django and Jinja 2 up on top for Python, Ruby on Rails in the middle, and that's some Node.js mustache templates on the bottom. And in every case, the developer is disabling auto-escaping for this field.
And so this is like whenever you're leaving the house and you're going to be back in a couple of minutes. You think, I'm just going to leave the door on the latch. I'll be fine. This isn't going to be a problem. And then, unfortunately, someone comes and pushes open the door while you're out.
Yeah, exactly. They're not going to, tiptoe around. They're trying to get in. And this, the middle example there with Ruby on Rails, the .html safe is actually a common error where people are disabling protection without even realizing it, potentially. It sounds kind of like HTML safe would make it safe, but it actually doesn't. It just marks it and says this is already safe, which disables the escaping. So it's common to make these mistakes, even if you don't intentionally want to disable escaping.
Okay, so this is something that Rails kind of needs to fix.
I think so, yeah. This has been lingering for a while, and they've done it well. They've added the auto-escaping. They've updated the docs with sort of big red bits about HTML safe, but it's still there.
HTML safe is not safe.
Yeah, exactly.
Okay.
Another problem is that the automatic escaping doesn't work in all cases. There's lots of different places where you might put data in an HTML template. The example we're showing here is where you've got an image tag and you're allowing the user to supply a link to the image. So normally the example in green here, they put in a link to a JPEG and it renders no problem. If you look carefully though, the developers made a mistake. They haven't put quotation marks around the attribute. So browsers are pretty accepting. So for the green example, it says, oh well, this is all part of the source thing, so I'll stick it in the source, and everything works. So you might not even realize there's a problem. But in the red example, an attacker has spotted this, and they've just simply added a space in the URL they provided. And then after the space, they've actually added a second attribute onto our image tag. So now we have a source going to a non-existent image, and this onError attribute is a JavaScript handler. So now when the browser tries to load fake, it's not going to load, no domain name, and it's going to fire this onError handler to handle the error, which is going to do our alert box and XSS achieved.
Okay.
And this is a good example where the automatic escaping doesn't protect you because it's not escaping that space. So obviously lesson is always quote your attributes, but obviously mistakes happen.
But it's a tension between the browser wants to not screw up the experience all the time. They want to be forgiving, as you say, but at the same time that forgivingness can cause problems.
Exactly, and browsers are notorious for this because every time there's a new browser, they try to support old websites that maybe they don't have quotation marks. So they try to keep them working even though they're not actually correct. So you have all sorts of these behaviors. Internet Explorer is notorious for this. But where there's weird behaviors that people don't quite realize are still supported, that maybe was the case way back in IE6, but are actually still affecting Internet Explorer 10 today.
Yeah.
So it's a problem. Here's another example where, okay, I've quoted things correctly. My attribute has quotes, but it's a link attribute, this href thing for adding a link to another page. So we've allowed a user to specify their home page on maybe their profile view or something like that. And instead of a normal URL like you've got in green, they use this JavaScript URL, which is another sort of, I'd say, legacy functionality in browsers. But now if somebody sees this link and they click the homepage link, instead of taking them somewhere, it's going to execute this JavaScript, and the exploit activates. So there's lots of ways this can be screwed up, and these are just some examples. There's a ton more, some even sneakier than these. Now, all these examples use alert boxes, which might be annoying, popping things up, but it's not actually that bad. But that's really just an example, a test to see if it works.
Okay.
Real attacks are doing things that are generally much more malicious. Here's a simple example where what this exploit is doing is it's grabbing all the cookies from the browser. So if somebody injects this script into my banking website, you say bank.com, and then the script executes, it's going to be grabbing all of the cookies from my banking site, one of which is probably a secure session token that authenticates me to the bank, and they're sending them off to an attacker-controlled website. So now the attacker can take this session cookie and pretend to be me. Another example that's a bit more sneaky. This one you'd notice because it's redirecting you to another site. But once you're executing script on a page, you can do anything you want.
Yeah.
This example has a form that's, initiating a bank transfer to the attacker's website, and you can see the script at the bottom is actually submitting the form automatically. The victim doesn't need to do anything. There's lots of protections for different types of attacks, like cross-site request forgery and things like that. But once you're executing script under the domain you're attacking, you can do anything you want. You can get, you can post, you can put, you can delete. Anything that JavaScript can do, the attacker can do. So you're basically wide open to attack.
Okay.
Okay, so now I'm going to drop into the demo. Okay, you should see an application up here now. For the demo, we're going to use an app called RailsGoat. So it's running in Ruby on Rails, and this is an application made by the OWASP project, the Open Web Application Security Project. And they have lots of resources and do a lot of work to try to educate developers about these vulnerabilities, cross-site scripting, and many others. And what they've done is they've made these sample apps. There's WebGoat, JavaGoat, a few other ones, or I think just WebGoat and RailsGoat. And these are apps that are intentionally vulnerable. They've added vulnerabilities on purpose for developers to play around with it and help them understand where the vulnerabilities come from.
Okay, that's pretty useful, having a tool like that.
Yeah, absolutely. So we're going to jump right into an attack, and you can see up here it's showing me my name as part of the welcome page. I'm logged in as the admin user. So I'm going to drop right into my account settings, and I'm going to enter an attack payload very similar to the ones we've been looking at just now. So instead of a name, I'm going to add in a script tag.
Okay.
So me being sneaky, and now when I submit, it's going to save that first name.
Okay.
And now if I reload the page, causing this little welcome message up there to reload, you can see before it reloads, it's popping up this alert box. That's my exploit, alert Redmonk demo.
Okay.
And you see up here the first name has actually kind of disappeared because what's up there is now the script tag, which doesn't render anything that's visible. Except, of course, the alert box.
So the user might notice that, but chances are high that they wouldn't in the application flow.
Yeah, exactly. And once you're here, you can do all sorts of things. So I can actually.
And of course, you can have that and the name as well, right?
And my exploit's still there, but now, it looks exactly like it used to. So I don't realize. Yeah. So there's lots of ways to be sneaky. And the cheat sheet that OWASP supplies with the application explains what the vulnerability is, how this has happened. And you can see the bug, the code that builds that little welcome message, actually has that same vulnerability we saw earlier. The developer has added .html safe, thinking that, oh, this will make it safe, but in actual fact, they're disabling the protection they had. So now what we're going to do is, this application here is connected up to Immunio, and we've got Immunio, which is just a gem file you install with your application. We've got it set up to monitor the application, but not actually protect anything. So if we flip over here, you can see it spotted that the application is being attacked. This is the app here, this Rails Go demo. You can see this is a typical dashboard. We're showing the threat volume over time. This is part of the demonstration here. Lots of threats today. There's our cross-site scripting in there. We also see who's doing the attack. This is me right here. But there's also other IP addresses that have been doing other types of attack. We can see general behavior over time. But what we're interested in today, right now, is this cross-site scripting vulnerability. So we're going to click through here. And it spotted a vulnerability in my application. So I'm going to click through, and we're going to take a look at what it's found. So you can see here, this is one of the attempts. And I'll actually find one, the Redmonk demo, the one we just did. You can see here, Immunio has automatically spotted where this vulnerability lives within my application.
Okay.
So it knows the file name, the line number, even the actual snippet of vulnerable code, which you can see matches the example that we just saw.
When it says protection was off, is that to do with the HTML safe, or is that something else?
No, so what this is showing is that Immunio has spotted the error, but it was configured just to alert you, so it hasn't done anything to protect you. So the protection is off.
Okay.
But you can see down at the bottom, here's the malicious payload, and Immunio is showing you what it would have done if protection was turned on. And you can see that even though Ruby on Rails with the HTML safe isn't escaping things, Immunio has spotted this and said, well, this is what Immunio would have done to protect you. And you can see it's doing similar escaping, it's removing the greater than, less than, and basically disabling the attack.
Okay.
So I'll actually demo that now, and you can see how easily you can go to a fully protected website. So I'm going to go into the settings.
So is it effectively sort of auto-generating the code that you need to remediate the issue?
Yeah, on the fly, Immunio is looking at this template being rendered. And you can see the example here. It spotted that, okay, this variable is getting put into HTML, like a body context for HTML. If it was going into an attribute, like up here, it would identify that it was going into an attribute, which might need different escaping. It'll even identify if you forgot to put quotation marks, like the example we looked at. It'll identify that and know that it has to escape spaces and many other characters to make that output safe against XSS.
Okay.
So we'll go in here. You can see Immunio also does account protection to protect against account takeover attacks. Code protection for lots of other vulnerabilities as well as cross-site scripting. And we also have this monitoring for suspicious behavior, things that might indicate somebody's trying to attack, even if your site's not actually vulnerable. You still might want to know who's trying so that you can block them or show them a CAPTCHA or disable their account or whatever you like.
Okay.
But we're just going to turn on escaping for cross-site scripting. So now whenever we see a cross-site scripting attempt, Immunio is going to take care of it for us. It's going to automatically escape it. So I save those changes, and so I just want to pull this up again here. So you'll see, that was from the last demo. Here, so yeah, protection was disabled, Redmonk demo. This is what it would have done. And now if we pop back to the application, I'm just going to refresh the page. So in the background, Immunio has automatically updated its settings. It already knows how it should be escaping. And let's see what happens. So you can see automatically, without restarting my application, Immunio is now flipped into protection mode. And you can see up here, it's automatically escaped these characters so that instead of executing, it becomes visible to the viewer here. So you'll notice if I refresh my page, no more alert boxes popping up. I can still see what the attack payload is, so it's a bit ugly, but it's not actually exploiting my browser.
Okay.
And, we can go in and we can change it to whatever we like. And you can see when I refresh the page, it'll update, but again, it's no alert boxes popping up.
Okay.
And if we go back into Immunio, it still sees we're being attacked because it knows somebody's trying to. But when I refresh my view of vulnerabilities, you can see somewhere in here we should, there we go, no more XSS.
Okay, and with that in mind, I mean, can you do alerts? Can you can you like do PagerDuty or anything like that to let people know?
Yeah, so we'll send out an email alert, but we don't actually do PagerDuty yet. It hasn't been a priority because this isn't something we need to wake you up about. Yeah, somebody tried to attack you, but look, Immunio is actually protecting you. So you're not actually vulnerable.
An application that can let you sleep at night.
Exactly.
Okay, well, I'm all about that.
Yeah, most people love that. And then it grabs lots of details about the attack, so you can see the payload, you can see the file, the line number. You can feed that to your developers so that they can fix it, but there's no rush. They can do it whenever they have time.
Okay.
Or if it's a legacy application, maybe you don't even have a development team active. So you can just leave it in protect mode. Immunio is going to protect you. The website works. It doesn't take any of your engineering resources from anything else.
Okay.
We do the same type of protection for SQL injection, remote command execution, file access on the server, redirects. We pull all that information together so that you can see the attacks. You can see how we're protecting you. User account protection serves CAPTCHAs automatically. It's basically a broad protection. Like we talked about at the very beginning, it's very easy to make web applications. It's very difficult to make them secure. The whole vision behind Immunio is we wanted to build a technology that you could deploy everywhere. Lots of different frameworks supported, Python, Rails, Node.js, Java, even more coming soon. This is technology you can deploy anywhere across the organization.
Frameworks, it would be like Django and others, because obviously frameworks and languages.
Yeah, that's right. So Django, Pyramid, Flask, Ruby on Rails, Spring and Java, Express and Node.
Okay, so this covers Spring and Java as well. Okay, I mean, I think Spring.
Yeah, that's right.
Okay, great.
And like I said, more coming. PHP, other frameworks. Our goal is to support as much of the internet as we can. This is something that could be deployed broadly everywhere and might actually raise the bar on internet website security everywhere.
Okay, so you sort of feel I mean, is one of the things that there's an education aspect here. Not everybody knows all the exploits, but I guess, with a combination of your stuff and stuff like out there, like the OWASP, hopefully that you can play an education role as well as a protection role.
Yeah, absolutely. Immunio really operates like a safety net. But a big part of our goal is this developer-centric view that we're grabbing the information about the vulnerability to help developers understand what is vulnerable, why it's vulnerable, and we actually give them the payload we saw so that they can, it's pretty much a built-in unit test case to verify that the fix went out. So yeah, giving that developer-centric view, the understanding and the learning is very important to us. If you want to give it a try, go to our website, sign up. We've got a free trial. You can give this a try on any of the frameworks I mentioned. We've also got lots of learning material on different attack types, different frameworks, giving you an idea of what you should pay attention to. Account takeover, what is that? How can you protect? How can you build? Lots of resources available. So come visit us.
Okay, great. From Redmonk's perspective, we always think that education is the best way to fix issues. So, I really appreciate you explaining to our kind of community a little bit about the common attack vectors and how they might be fixed or watched out for. So that's awesome. Thank you very much, Mike Milner. And thank you all for joining us.
Yeah, thanks for having me, James.